or compound we're going to draw is carbon monoxide. So again, we can look at the Lewis dot structures that we made on 5.17. Carbon has 4 valence electrons. Oxygen in group 6A has 6. So we have a total of 10 valence electrons that we can distribute. Both carbon and oxygen have space in their valence shell for 8 electrons. So 8 times 2, because we have 2 atoms here, equals 16. For this next one, we know that the shared valence electrons is wants minus has. So our wants is 16, our has is 10. So we are going to share 6, meaning that we're going to make 3 bonds. Okay, so now we only have 2 atoms, so we know that they're going to be kind of right next to each other. So we can go ahead and just write them like this. And we're going to draw one single bond between them. This one single bond represents 2 shared electrons, but we know that we need to have 6 shared electrons. So that means that I'm going to have to add some more bonds. Remember, each line represents 1 bond, and each bond represents 2 shared electrons. So I have 3 bonds between these, so I have my 6, so that's great. But right now, each atom only has space for, or only has access to 6 electrons. Each wants access to 8 electrons, and we still have 4 extra electrons that we need to distribute. So if I do 1, 2 there, then this carbon has access to 8 electrons because it has access to 6 through these shared bonds and 2 here. And I can add 2 more here on the oxygen. And now oxygen also has access to 8 electrons because it has access to 6 electrons here that are shared and these 2 here. We can also do the final count to double check that there are only 10 electrons being used. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.